morning, precalc fans. How we doing this fine, sunny Monday morning? Yes, it is Monday morning. Hope everything's going well with you and your family. Hope you're staying illness-free. It's a beautiful day out there right now. It's a little chilly at this point, but the weatherman says it's supposed to warm up. That's going to be good. We can get outside. So like on Saturday, that was nice to be able to get outside and just do work outside and not have to bundle up or anything like that. It was really nice to be able to do that. There's a couple of you still have not turned in the evaluation from last week. Please continue to work on that and get those turned in. Everybody else has turned it in. You've done a nice job with them. I've been impressed by the work that you've done and keeping up with the material. Continue to do that. Like I said, you've done a nice job. It's a different way of learning, and that's fine. That's what an open mindset is and a growth mindset is. I don't have to be sitting in the classroom every day to be able to learn material. I can be able to learn material as I go through, either watching videos or learning some things on my own or going back to my previous knowledge of what I've had before. You've done a nice job with this, so keep it up. We have 4 more weeks of this. Let's continue to push ourselves through this, and we'll get back to some sort of normalcy as quickly as possible. It'd be nice. Today what we get to do is we get to go back. The first couple sections this week, these 2 sections this week are all review for you. Okay, the review from trig class that you were in last year, and also the review from when you're over there in Dr. Clark's class dealing with the law of sines and law of cosines. So this should be something that should be familiar with you. We continue to go through it because it's an important thing to realize how to work with specific triangles, even though it might not be a right triangle. Okay, everything in the world is not going to be a right triangle. So how do we deal with this? We still want to be able to create relationships with the right triangles. If we don't have a right triangle, we can't use our Pythagorean theorem. We can't be a part of the brotherhood. We have to be able to utilize other ideas. And it's sort of set up with respect to law of sines and law of cosines as the ideas of some of the Pythagorean ideas. And we'll see that tomorrow a little bit more when we deal with the law of cosines. But today what we're going to deal with is the law of sines in the area of the triangle because they are intertwined with each other. One is dependent on the other. If we take a look at the area of a triangle, how we calculate the area of a triangle? If you remember that back, area is equal to 1/2 times base times height. That's the area of any triangles, 1/2 base times height. But what we have to remember is, what is our definition of a base and height? Or our base can be any side. It does not have to be just the bottom side. It can be any side of our triangle. Well, here we have triangle bend, okay, or neb, or knee nub, or whatever you want, bend. If you remember back how we label triangles, the capital letter is big B, that's our vertice point. The side opposite is the lowercase of that, so that would be little b. This is big E, so this would be little e. This is big N, so this would be little n. So any of these 3 sides can be our base. Does not matter if it's this side, or this side. Any side can be the base. Does not have to be the bottom side. The height is a segment perpendicular to base to opposite vertex. So we can have the segment perpendicular to the base to the opposite vertex. This is what the height is. Okay, we always go perpendicular. Well, what I'm going to do is I'm going to use E as our base. I'm going to use E as our base because I want us to get out of the idea that it has to be the bottom value. Any side could be the base. And I'm going to draw in my height. My height is a segment perpendicular to the base to the opposite vertex. Okay, this is called an auxiliary line. Okay, it's the line that's going to be drawn in there to help us out. So what we're going to do is we're going to take a look at this triangle and look how we can calculate the area of this triangle. Well, my base is E. So my area is 1/2 my base, which is E, but my height is this value here, H. We want to be able to calculate this value here. Well, let's take a look at, we have two triangles here, triangle 1 and triangle 2. When I drew my auxiliary line in there, I have two right triangles that I divided into. Let's look at triangle number 1, which is, we have B to E, and we have this segment going down, and then we have this segment to go there. So what we have is here is our big B. This entire side here is N, and this is our height. What we want to do is we want to create relationships that involve sides and angles of our entire triangle, our big triangle. We have this big triangle here. I want to use sides and I want to use angles of that big triangle. So if we take a look at triangle number 1, I have entire N, I have angle B, and I only have a partial of E. E would extend on, so I'm not going to draw that in. All I really worry about is this H. And this is a partial of big E. I don't have entire big angle E there. So if I take a look at triangle number 1, I have this right angle here. I know this entire angle B. I know this entire side N. And I want to determine a relationship with this H. So one must ask themselves, which trig ratio relates this angle B to this side and this side? Well, here's my angle B. This is my side opposite my angle B. Here's my hypotenuse of this right triangle. That is correct. The sine of angle B is equal to H over N. Now if we multiply both sides by N, we have our height is equal to N times the sine of angle B. So up here I have 1/2 base times my height. My height is N sine of angle B. So I can calculate my area of this triangle using this formula. But if I take a look at triangle number 2, in triangle number 2, here is my H. I know this entire side B. I know this entire angle N. So with this entire this triangle number 2 here, here is B, here is N, and here is H. And here's my right angle. Once again, what's trig ratio relates angle N to H and B, and that's still sine. So H, in triangle number 2, H could equal, the sine of angle N, take it back one step, the sine of angle N is equal to H over B. So we can multiply both sides by B. So H could equal B times the sine of angle N. So up here, I can rewrite this area as 1/2 E times B sine of angle N. So this could be another way of calculating the area of the triangle. Well, for any triangle, there's 3 formulas that you can utilize. 3 of them. Well, we just wrote 2 of them up here. We're going to use our noggin to figure out the third one. We have 1/2 EN sine of angle B. Then we have 1/2 EB sine of angle N. What would be our third one? We have EN sine of angle B. Then we have EB sine of angle N. Well, the other angle that we have not used is, okay, we've used B, we've used N, we haven't used angle E. We're going to still include the 1/2 in here. But here we have EB sine of angle N. Here we have EN sine of angle B. What two sides do you think we have to multiply to get our third formula to use the sine of angle E? Well, we have EN sine of angle B, EB sine of angle N, angle E. Let's take a look. E and N with angle B. Then we have E and B and angle N. Now I'm using angle E, the two sides that we have to multiply together. That is correct. N times B times the sine of angle E. So here's our three formulas for the area of a triangle. Now if we take a look what occurs here, we have N and B and we use angle E. But then we have N and E, we use angle B. Then when we have E and B, we use angle N. Well, what's the relationship between these two sides we're multiplying and the angle? These two sides and the angle, or these two sides and the angle? What's the relationship? That is correct. Those two sides make up that angle. The two sides make up the angle. So what we say when we have two sides that make up the angle, we have two sides and the included angle. So when we talk about the included angle, it is the angle formed by the two sides. The angle formed by the two sides. So any triangle, we have our area is equal to 1/2 times the product of two sides times the sine of the angle included. So we have 1/2 the product of any two sides. Product means we multiply. Product means we are multiplying two sides together, and the sine of the angle and the angle included is the angle formed by the two sides. What this allows us to be able to do is develop what is called the law of sines. The law of sines uses the area of the triangles. The area could be 1/2 EN sine of angle B, 1/2 BN sine of angle E, 1/2 BE sine of angle N. It's what we developed on the front side. All three of those should come down to the exact same area, or close enough, because we're going to be using approximations. You might be off by a little bit. Well, these things should all be equal, and I'm going to use my properties of equality to be able to simplify things. The first one is I'm going to multiply through by a value of 2. Morning, Mr. McFerrin.
Morning, Mr. Greger.
I'm going to multiply all of my sides by a value of 2. What that will do is it will clear my fractions out, so we're left with EN sine of angle B is equal to BN sine of angle E, which is going to equal BE sine of angle N. Now we're going to divide through by the product of Ben. Okay, we're going to divide through by that. Now, it's a triangle, so we're assuming that we have a triangle. That means we have three specific values. We don't have a value of 0 for any of the sides. So we're going to multiply or divide through by the product of Ben. Well, what happens nicely is the E's cancel and the N's cancel. Here the B and the N's cancel. Here the B and the E's cancel. So what we're left with is the sine of angle B over little b equals sine of angle E over little e, which is equal to sine of angle N over little n. This is what we call the law of sines. It tells us for any triangle, the sine of the angle over the length of the leg or side opposite will be in proportion. The ratio of the sine of an angle to the length of the side opposite will be equal throughout the entire triangle. Let's take a look at Triangle Timmy. And Triangle Tim, once again, as everything that we've done here in the math world, draw a picture, draw a picture, draw a picture. Now all my triangles are going to pretty much look the same. Okay, I'm not going to draw them to scale or anything. They're all going to look like this. And you need to label however you want to label that. What I typically do is I start with top, T, then I go left to right here, but that's just me. It's my little quirk that I have. Angle T is 40 degrees, angle I is 60 degrees, and little I, which is opposite big I, is a value of 10. We want to find little t and little m. The first thing I want you to do is write down the 3 law of sines ratios that we have here. What would be our 3 law of sines ratios? That is correct. We have the sine of angle t over little t is equal to sine of angle I over little I, which is equal to sine of angle m over little m. Those are our 3 law of sine values. Now if we take a look, I have 60 degrees with angle I. I have 40 degrees with angle T. And I know little I is a value of 10. So if we take a look at our first 2 ratios here, we know 3 of the 4 values. Well, if I know 3 of the 4 values, I can solve that proportion. So we have the sine of angle T. Whoopsie. The sine of 40 degrees over T is equal to the sine of 60 degrees over 10. And what we have to do is solve the proportion. Well, if we have to remember how to solve a proportion, we cross multiply and then we divide. So we have 10 sine of 40 is equal to T sine of 60. We can divide both sides by the sine of 60. Which will cancel these out. So within the calculator, we have 10 sine of 40, 10 sine of 40 divided by the sine of 60, we get 7.42. Now last one is I want to find, see, little t, oops, my bad, I goofed that up. Little t, 7.42, that's a little better. Now I want to find little m. I want to find little m, I need to know big M. Well, how do I find the measure of big M? Well, let's think about this. The angles of a triangle have to add up to 180 degrees. So if this is 40 degrees, this is 60 degrees and 40 degrees. That means this has to be 80 degrees. So I now know this to be 80 degrees. And once again, I would probably go back to these, the ones I know for sure. I wouldn't use this one because I goofed up. If I goofed up finding little t, I'm going to goof up finding little m then. So we have the sine of 60 degrees over 10 is equal to sine of 80 degrees over little m. Once again, you can cross multiply. You can cross multiply here. Go ahead and cross multiply and then divide. Sine of 80 divided by sine of 60. We get 11.37. Now, in terminology that you'll see in a book, they'll ask you to solve a triangle. When they ask you to solve a triangle, basically they ask you to find the values. Let's calculate the area. And it does not matter what sides you use and what angles you use, does not matter. I'm going to use angle M. Why? I don't know. So we have 1/2 t times I times the sine of angle M. Okay, if I wanted to use angle I can multiply M and T with the sine of angle I. If I want to use M and I can use the sine of angle T. Does not matter. So we have 1/2 T, which is 7.42, times I, which is 10, and then the sine of 80 degrees. So we have 0.5 times 7.42 times 10 times the sine of 80 degrees. And we get 36.54. And these are squares. These are very independent or dependent on each other. The law of sines and the areas of the triangles are dependent on each other. We have to use our areas of the triangle to be able to determine the law of sines. Law of sines is nice to work with in regards to being able to deal with calculations. It's not very difficult, it's just a matter of solving proportions. But every time you need to do this, you need to make sure you draw a picture so you have a picture that you're looking at to be able to set up your law of sines equations and your area equations. Other than that, I have nothing else for you. I put a worksheet for some practice on Progress Book for you. Not Progress Book, how about on Google Classroom? So you have a worksheet there on Google Classroom to be able to access, to be able to work yourself through some problems, give yourself a little bit of practice. Tomorrow we'll come in and we'll deal with the law of cosines. Wednesday will be a combination of both of them put together. Thursday will be the evaluation on law of sines and law of cosines. Sort of the same type of process we've gone the last couple weeks. If you have any questions, feel free to comment me. I'll be more than happy to answer any questions. Once again, you've been doing a very good job. Continue keeping up with the material. Those that have a couple things you still have to be able to turn into me, get them turned into me. I try to update Progress Book as quickly as possible. Try to get the grades in there as quickly as possible. Other than that, I have nothing else for you. Stay safe, keep your social distancing out there. Enjoy some nice weather hopefully today. Adios, we'll see you guys tomorrow. Miss you guys.